Alright, let's do some homework. Come on. Alright, I didn't bring the paper with me, so these numbers might not be exact, but we can give you a good idea of what's going on here. So this paper we did for homework tonight is all about surface area using nets. Surface area with nets. Okay. So one thing to keep in mind here if you're doing nets is the formula chart way of doing this, which is like on a prism, you'd say the total surface area is perimeter of the base times height plus 2 times the area of the base. This doesn't always work the best with nets because it's a little bit harder for some people to conceptualize where the base actually is. Okay, so what I would usually recommend if you're dealing with nets is to just find the area of each piece and then just add them all up at the end. Like in this case, we have a rectangular prism. We have one rectangle that's 9 by 2, so that has an area of 18. Since it's a rectangular prism, it will always have a corresponding congruent side somewhere else. So this one would also be 18. Okay, then we have our little bit bigger rectangle here, which would still have this length of 9, but a height of 3. So 9 times 3 is 27. Which would correspond with this one down here. And then we have our smaller rectangles on the side that are 2 by 3, which is 6 and 6. And then if we were to just add all these numbers together, 18 and 18 is 36, and 27 and 27 is 54, and 6 plus 6 is 12, and we can combine these all together, and this would give us 2 and carry the 1, 102. And then that's, I don't know what this was, it might be inches, so inches squared. Okay, now this formula could work if we picked one of our rectangles to be the base. So let's say we picked this blue one here. Okay, so the area of our base would be 18. The perimeter of this would be 9 plus 9 plus 2 plus 2. That would be 22. And, well, 2 is just 2, so that's not so bad. But then the height, you have to think, what is the height? And generally speaking, on a rectangular prism, the height is whichever dimension you didn't use as part of this rectangle. So we used 9 and 2, which means we didn't use 3. Which means our height would have to be 3. Okay, then we just do our math here. 22 times 3, that's 66. 18 times 2, that's 36. And this still would give us 102. Okay, so you have options, but with nets I would recommend this strategy here. Okay. Alright, another question you had involved a pyramid, but there it's the way it's worded, we said we wanted everything except for the base. So if we don't want the area of the base, we were looking for lateral surface area. Actually, I might have that backwards. It might have said find the lateral surface area, which means we ignore the base. Okay, and we know if it's a pyramid, the base is the shape that's not a triangle. Okay, unless it was a triangular pyramid. Like if this was our base, and then our lateral faces would look like that. So it's always the shape in the middle. Okay. So again, same idea. We take the area of our pieces. So if we want the area of just this triangle here, we say area of a triangle is half the base times the height. And we know base and height have to meet at a right angle, so that's got to be this 4 and 3. And then we just do our math here. I can say this is 12, and half of 12 is 6. So I know the area of each of these triangles is 6. Okay. And now, since it only gave us one side, probably assume that this is a square, which means these other sides would be 4. And since this is a proper pyramid, it means all the heights would also be the same. And if the base and height are the same, well, guess what? Then these triangles are the same, which means all of these have an area of 6. So our total area would be 6 times 4. And again, I don't think I have the right numbers here, but it's the basic idea. You find the area of 1 and multiply it by 4 since there are 1, 2, 3, 4 triangles. If it said, instead of lateral, it said total surface area, you would do the same thing, except you'd actually need to find the area of the square as well. So that would be 4 times 4, which is 16. Then we just add them together and get 40. Okay, so we have our total, and we have our lateral. Okay, and everything else basically follows the same format, and I'm sure you can figure it out, and if not, you should have come to tutoring where we were giving out M&Ms. Okay, so that's it for 7th graders, so go have fun with that. Alright, 8th graders, we're doing arc measurements, which is a lot of fun. So our basic example here, we have 2 cases. We're looking for central angles, and we're also looking for arc measurements, and we know that these are interchangeable ideas. So like if we say the measure of angle thou, which is this piece here, that this angle is exactly the same as the measure of arc vu. Okay, and either way you look at that, 7%, so this is 7% of a circle, so it's 7% of 360. So we say, what's 360 times 0.07? And that comes out to a number, I don't care what that number is. Okay. Really what I wanted to look at this is we have our second two, arc mu and arc upt. And we talked about this a little bit in class, but some people don't listen in class and some people need reminders, so here's your reminder. So the reason why these are different, ut is this arc right here, from u to t. Okay. And now we would call that our minor arc, because it's less than 180 degrees. It's just this little piece right here. There's also another way to get from u to t, which is to go the long ways, which is why they signify, what is a different color? They signify p, right? And all this tells us is that instead of going directly from u to t, we're taking the long way around. Perfect circles, bam. Okay, upt. Okay, so when you're writing arcs, generally speaking, if they give you 2 letters, it's just, short distance, look for your minor arc. If they give you 3 letters, there's a good chance it's probably telling you actually want the major arc. Okay, so if MUT is 10%, so this would be 360 degrees times 0.1. And UPT is everything else, so this would be 360 degrees times, let me do this fancy, we can say this is 1 minus 0.1, or just 360 times 0.9. Okay? And then these problems go together really well, because if we know this is 36, then we know that this is just 360 minus that, which is 324 degrees. This is all in degrees. Okay, so that's not too bad. Alright, down here we have 2 circles that are congruent, and we said if the circles are congruent, so if the circles are congruent, then the radiuses are congruent. Okay, which means, it doesn't even matter for this one, but this is still true. So we can say CD, this arc is the same as this arc here. And we said today that if the arc lengths are the same, then this central angle is also the same. Okay? Which means we can just do a little bit of algebra here. We can say 45 minus 6x has to equal this one over here, which is negative 9x. And then we just do math. Is that right? Really negative? Am I going crazy? It is negative. Alright, well, let's see what we get, and then I'll decide if I've gone insane. Okay, because this doesn't look like it's going to work out right. So let's move 6x over here. So this gives us 45 equals negative 3x. Oh no, this is going to... Duh, never mind. Okay, we're okay. We divide both these by negative 3. And this is going to give us x is negative 15. Okay. And then since we don't actually care what x is, we want measure of EBF, which is this right here. So we just say if that's negative 9x, and we know x is negative 15, we can say negative 9 times negative 15 is 135 degrees. Right? 15, 9, 5, 4, yeah, 135. Okay. I was worried because I knew this was going to come out negative, but negative times negative is positive. Okay. Because, you know, if what I was worried, really, the big problem was if this came out to a negative degrees, that doesn't exist, and that would be sad times. But it's not, so happy times. Okay. Last one. We didn't really talk about this because, I don't know, this seems like a good problem-solving opportunity for you. Okay? We're given very minimal information. We know, what do we know? We know this. We know that it gives us this information. We know this length is 8, and this little length is 5. And what we probably could have told you today is that if they're perpendicular, then this is the same as that. Okay? And hopefully you come up with that on your own. Hopefully, right? Okay, so what we need to figure out is what is this length here? And so we say, can we make some right triangles? Of course we can. So if we say this length from P to R, and then how long is this? Well, this is a radius. So we see, do we have any other radii? And of course we do. We have this one here, which is 8 plus 5, and 8 plus 5 is 13. So now we have a right triangle with one leg of 5 and a hypotenuse of 13, and we recognize that's a triangle we've seen many times before. So this is a 12. Okay, 5, 12, 13. You can work that out if you don't believe me. Okay, so if this is 12, then this is 12, and then RS, which is the distance across, will be 24. Okay, that wasn't so bad. And we'll practice some more with this tomorrow. And then we can start learning how to find the actual measure of how long the arc is. Ooh, I didn't expect that to happen. Okay, so that'll be fun. So, be ready for that. Okay, good night.